Hey guys, welcome to my channel. My name is the online teacher, and in this video we will be covering glycolysis. At any time in the video, if you're enjoying what you're watching, then don't forget to hit the like button and subscribe to keep up to date on our future content release. Without further ado, let's begin our video. The first thing we need to do is identify what our learning objectives are. You should always refer back to your spec points. In this video, we're going to be looking at the AQA spec, which is this, and the OCR specification, which is on your video right now. So please do pause the video and have a read of your spec points. Right, let's draw glycolysis. Here is the diagram of glycolysis, and you're probably looking at it thinking, wow, this is really complicated, but it doesn't have to be. What we can do is simplify it. Let's go all the way down to basics and let's start from there. We can start by drawing a carbon atom first, a hydrogen, and a phosphate molecule. Now these molecules will be key in the whole of glycolysis. Let's draw the molecules that are involved in glycolysis. First up is our 6-carbon glucose. Then is a 6-carbon with a phosphate molecule called fructose 6-phosphate. 6-carbon compound with 2 phosphate molecules called hexose 1,6-bisphosphate. 3-carbon compound with a phosphate called triose phosphate. A 3-carbon compound with 2 phosphate molecules called triose bisphosphate. A 3-carbon compound called pyruvate. NAD with hydrogen, which is called reduced NAD, dehydrogenase enzyme, ATP, and ADP, and finally an inorganic phosphate ion. This is our team. We will use these molecules to draw a glycolysis diagram. Let's draw a glycolysis diagram now. Looking at this diagram, isn't this diagram more visually pleasing than the previous one? If you agree, then please do hit that like button. We can break down the glycolysis diagram into 4 different phases. Phase 1, or part 1, which is referred to phosphorylation. Part 2, which is lysis. Part 3, which is phosphorylation once again. And part 4, dehydrogenation. Let's look at step 1. In step 1, 2 ATP molecules are hydrolysed to remove the phosphate ion. The phosphate ion combines with glucose to form hexose 1,6-bisphosphate. Key points for this step are 2 ATP molecules are hydrolyzed. The energy released from the breakdown of ATP is used to attach the inorganic phosphate to glucose. This causes the glucose to become unstable and prevents the glucose from actually leaving the cell. The purpose of it is to just basically make the glucose become unstable. In step 2, the unstable hexose 1,6-bisphosphate breaks down into 2 triose phosphate molecules. The triose phosphate molecules are further phosphorylated in step 3 to form triose bisphosphate. The inorganic phosphate molecules that makes triose bisphosphate are free floating in the cytoplasm, and that's where they come from. The triose bisphosphate then move into the final phase, which is step 4. And in this step, the triose bisphosphate are dehydrogenated, which is the removal of hydrogen by the enzyme dehydrogenase. And NAD picks up these hydrogens and becomes reduced NAD. This happens twice. This is because you've got 2 triose bisphosphate molecules that are formed from one glucose molecule. After dehydrogenation, you get 4 ATP molecules which are formed, 2 per triose bisphosphate molecules, and they are formed due to substrate level phosphorylation. The dehydrogenation and decarboxylation of triose phosphate forms the end product of glycolysis, which is pyruvate, which is a 3-carbon compound. This is the overview of glycolysis. Just look at how amazing the whole process is. Next, what we'll do is we'll summarize what glycolysis is. We used 2 ATP molecules to destabilize our glucose, and at the end we formed 4 ATP molecules which were due to substrate level phosphorylation. 2 reduced NADs were formed from dehydrogenation of triose phosphate. No reduced FADs or NADs were formed. The enzymes involved were dehydrogenase, NAD was our coenzyme, and we had substrate level phosphorylation and dehydrogenation occurring, but we had no decarboxylation. Pause the video if you need to, get this table drawn up or summarized for yourself. Alright, it's time to test your learning. For each question, I'd roughly give a minute per mark. This question that we're about to see is worth 5 marks. So what I would do is give yourself 5 minutes and have a go with the question. And once you're ready, then obviously play and resume to go through the answers. The answer to the first question is glycolysis occurs in the cytoplasm. The second question, the answer is as follows. Glucose is phosphorylated, hexose 1,6 bisphosphate is formed. The hexose 1,6 bisphosphate is broken down into 2 triose phosphate molecules. The triose phosphate is dehydrogenated, pyruvate is formed, and finally there is a net production of 2 ATP molecules. Check your answers, correct where you need to correct them, and just basically tally up your marks to see how well you're getting on. For the next question, do the same, pause the video, and once you've answered the question, then you can always play again. For the first question, once again, the diagram represents what we've been learning about, which is glycolysis. Just like the previous question, glycolysis occurs in the cytoplasm. For compound D, we add compound D to convert hexose phosphate into hexose bisphosphate, and that can only be ATP. For E, from the diagram gets reduced, and we know that NAD gets reduced, so E can only be NAD. And finally, we get 2 products, which are the end products of glycolysis, and that is pyruvate. Give yourself a mark out of 10. If you scored less than what you wanted, then perhaps you just need to watch the video once again. The more you watch, the more you'll learn. So please do feel free to watch the video again multiple times if need be. I mean, why wouldn't you? Congratulations, you've made it to the end of our video. You are probably feeling that bit more enlightened, that bit more knowledgeable, and you think you can take on the world when it comes to biology. We are glad you feel that way. If you don't, that's perfectly fine. That's why the comment section is there for us to help you out with anything that you perhaps weren't too familiar with. If you feel like you need to watch the video again, then please by all means do so. And don't forget to like, subscribe and share the video with your friends, families and colleagues. Once again, thank you for your views and we shall see you in the next one. Take care.